This is a video on the type of a triangle. The question states, determine if the triangle with vertices 1, 2, 0, 3, 5, negative 1, and 0, 2, 3 is an acute triangle, an obtuse triangle, or a right triangle. So I'm going to find vectors that go from the first point to the second point, the first point to the third point, and the second point to the third point. So first, let's call the first point to the second point vector u. And that's 3 minus 1 is 2, 5 minus 2 is 3, negative 1 minus 0 is negative 1. Let's call the vector that goes from the first point to the third point v. And that's 0 minus 1 is negative 1, 2 minus 2 is 0, and 3 minus 0 is 3. And then the third vector will go from the second point to the third point. I'll call that w. 0 minus 3 is negative 3, 2 minus 5 is negative 3, and 3 minus negative 1 is 4. So I've sketched a diagram of what that triangle might look like. So let's consider this angle right here. And to find the cosine of that angle, I'm going to take u and dot it with v and divide by the magnitude of u times the magnitude of v. In particular, if I take u dot v, I get 2 times negative 1 plus 3 times 0 plus negative 1 times 3, and I get negative 5. For this angle here, notice that w emanates from that point, but u is backwards. So I'm going to look at the dot product instead of u and w, but negative u and w, so that I can look at the vector that emanates from that point instead of to the point. And I have negative u dot w is negative 2 times negative 3 plus negative 3 times negative 3 plus 1 times 4, and I got 19. Now let's look at this third angle, and we'll notice that both v and w go towards the vertex instead of away from it like we'd like. So we need to find the dot product of negative v and negative w. So I worked that out, and I get 1 times 3 plus 0 times 3 plus negative 3 times negative 4, and that becomes 15. So those are the dot products. And the important thing to note is that the cosine of the angle always has the same sign as the dot product, because when we take u dot v and divide by the magnitude of u times the magnitude of v, the denominator is just a product of magnitudes that's always positive. So that tells you the cosine of the angle between vector u and vector v is negative. Well, a cosine is negative whenever that angle is obtuse. So in particular, I have an obtuse angle, I have an acute angle, and I have a second acute angle. But for any triangle, if one of the angles is obtuse, then that triangle is an obtuse triangle. So I can conclude that the triangle that I have is obtuse. And I'm done with the problem.